Hello, my name is Irfan Zafri and we are from Group 11 are going to present about H1 stream flow measurement. In hydrological study, it is important to quantify the flow of rivers. The characteristics of flow are depth, cross-section, velocity and stream discharge. By using velocity area approach, all these parameters are being integrated. The main equation in this experiment is Q equals to V times A, where Q is stream discharge, V is the average velocity and A is the cross-sectional area of the stream. This experiment also strengthened the understanding of conservation of mass. The calculated discharge and nearby cross-section is the same even though the depth and the velocity are different. In measuring the flow velocities, two methods are being introduced which are using the current methods in floating object.
The objective of the experiment are to measure average flow velocity at cross-section, to calculate stream discharge using the concept of velocity area, to strengthen the understanding the conversion of mass concept at river ridge, to select suitable stream cross-section in river gorging, and lastly to use and appreciate safety gears during river gorging.
Discharge is the volume of water moving down a stream or river per unit of time, commonly expressed in cubic feet per second or gallons per day. The equation used is Q equals VA, where Q is the discharge in meter cube per second, A is the cross-sectional area, and V is the velocity. So, one of the stream flow measurements used is the current meter method. This is one of the most common methods used for fast-flowing water. So basically, the stream channel cross-section is divided into numerous vertical subsections. In each subsection, the area is obtained by measuring the width and depth of the subsection, and then the water velocity is determined by using a current meter. The discharge in each subsection is then computed by multiplying the subsection area by the measured velocity. Next is the floating object method, which is fairly inexpensive and simple. It involves measuring the surface velocity of the water with a floating object and then multiplying this velocity by the width and average depth of the channel. Although it is not as accurate as any measuring devices such as the plume or a flow probe, the floating method provides an educated estimate.
Hi, my name is Lo Yan Fong. Now I will talk about the procedure of the experiment. So this is the measuring depth, this is the hammer, this is the velocity meter, which is the current meter, and this is the steel rod for the measuring rod. This is the steel rod for the river bank, and also the life jacket. So the procedure of the experiment, first step, the appropriate channel section is chosen for the upstream. Now I will use the riverbank marker steel rod. Now I will use the measuring tape to measure the stream width. Okay, next, we will divide the stream cross section into the numerous vertical subsections. Okay, next, we will use the measuring rod to measure each stream flow depth of each subsection. Next, we ensure the flow is stable, and then we use the current meter, which is the velocity meter, to measure and record the average flow velocity in each subsection. The whole step is repeated for the downstream, and then the experiment must be taken as 3 times. Next, I will talk about the second method, which is the parting method. So we identify the river, and then we identify the stream A and stream B, which is the upstream and the downstream. After that, we need to know the width and the length of the river, so we measure it. After that, we have measured the river, we know the length and the width. we use the flooding device. This is the flooding device, and then we need a stopwatch. So this is the stopwatch, and then when I put the flooding device, and then we need to measure the time. So let's start. So we see when time goes. After that, when the flooding device reaches the end of the stream B, we will stop it. So we will put it as the data for our. That's all for today. Thank you.
Good day, everyone. Today is our discussion. So I'm going to present our result analysis for our H1 net. First, I'm going to talk about the upstream cross section. We got for the area of the upstream cross section, the total area is 0.514 meters squared. And then for method 1, current meter method, the total discharge for the current meter method is 0.2051 meter cube per second. And then for method 2, floating object, we got 0.2904 meter cube per second, and the discharge percentage difference is 41.59%. Next, we move on to downstream cross section. The total area for the downstream cross section is 0.76 meter square, and then for current meter method, the total discharge is 0.2691. Then we move to method 2, which is floating object method. The total discharge is 0.2109, and the percentage difference between the two methods is 21.60%. Okay, next we move on to discussion. Go, Shaya.
Okay, so for discussion, based on our result, we found that the stream flow percentage difference for upstream and downstream is 41.59% and 21.63% respectively when we calculate using current meter and also floating object method. The difference is quite large for both method. So this may due to some error while doing the experiment. Basically, this test is conducted in real situation, so maybe the dimension of river is not properly taken. Also, the riverbed is not constant as the soil is soft and have segmentation, so that might affect the real depth of each section of the river. Besides, the current meter is not exactly placed at the design depth, which is 0.6 y, which result in inconsistent value of velocity for each section. Other than that, parallax error when taking the measurement of depth and width of the river. So in order to minimize the error, at least 2 students need to take the measurement to avoid parallax error, and also the readings can be done several times to obtain the average. We can also increase the number of cross sections so that we can minimize the error. And in conclusion, we managed to get the discharge for upstream and downstream cross section using current meter and also floating object method. For the current meter, we use mean area section method. We also understand the conservation of mass concept at river ridge, and the result for both methods should be similar, but there is differences due to